point, I'd like to welcome Mitchell Hashimoto, founder and CTO, to the stage. Thanks so much.
All right, hello everyone. Before I get started, a lot of the people that worked on what Armand just talked about in Terraform, they've been working on all that for a couple of years now. I think it's amazing. If you think it's amazing as well and want to thank them, could you just give them a round of applause right now, please? Thank you, Terraform team. Cool, so it's amazing to see you all here today. I am going to be talking about Consul. I've been really excited about Consul lately. For those of you who have been watching multiple of our events or have been to multiple keynotes, you may notice that either by choice or by luck, I have gotten the Consul section 4 events in a row now. That's not really a mistake. I am really excited about Consul. And why is that? You know, Consul is exciting to me because it is chipping away at solving this very important service networking challenge. Armand explained the challenges of multi-everything, and networking really sits at the core of that. And to show you visually what I mean, when we've been talking about multi-platform, this transition has been going on for a very long time. If you zoom out sort of to 3 or 4 decades, you could begin at mainframes, and if you find any company that's been around long enough, you'll see almost all of these still in action today. The mixed technologies, the multi-platform, multi-paradigm that's going on is still very much active, right? There's mainframe to bare metal to VMs, and then recently containers and serverless. But even though containers or serverless are recent, the notion of paradigm shift and technology change in a company is not new. And when you look at all of these things, they still interoperate today, they still work together today. And the one thing that has always been there as a least common denominator, the one thing that has made applications on different platforms always work, has been the network. No matter how much changes above, we've always been able for the past few decades to rely effectively on TCP to be there for us in order to make everything work. So any protocols that live on top of TCP sort of enable us to connect things like containers to mainframes. And even for newer sort of cloud native or cloud first companies that started with cloud VMs, they've now had to endure the paradigm shift of container platforms and serverless. So sort of much in the same way that when cloud was coming up and those companies got to point and laugh a little bit at the companies stuck with physical data centers, they're now being pointed and laughed at for being stuck with cloud VMs as people move to containers and are realizing the very real business challenge of having mixed technologies and sort of the importance of the network underneath to make this all work together. And so when we look at the network and try to use that as a solution for these mixed technologies, we run into 3 key challenges. There's the challenge of naming, authorization, and routing. Naming is the most simple challenge. It's the one you run into first, typically. It's really basic. It's just what do you call something in order to address it? You know, when the web service needs to talk to the upstream auth service, how does it tell the network that it wants to talk to that thing? Traditionally, we've sort of used IP addresses, and particularly static IP addresses or virtual IP addresses to make this a reality, to give something a fixed name so that when we say, you know, in this example, .51, we know that we mean to go to the auth service. When you had very static machines, this worked totally fine. As we've sort of scaled out horizontally, and in this example having multiple auth services, you still want some sort of fixed name to make this consistency. And historically, in a traditional static environment, as Armand showed, you would reach back into load balancers for this solution. And these load balancers are doing very little in terms of what they're capable of. The primary thing that they're solving here is the naming challenge. Load balancers don't change very often. Their config does, but the machines don't. So you're able to keep this static address and route it to these more dynamic backends that are coming and going. As we look forward into sort of a console-oriented world, we've begun to replace these IP addresses with the actual logical service names instead. So instead of asking for .51, you explicitly use DNS to ask for the auth service, and Consul dynamically figures out where that goes, and you're able to eliminate load balancers for this particular solution. And this is generally what people adopt Consul first for. We've seen multiple talks. There was one at HashiConf EU a few months ago and last year. We've seen multiple talks from our own users and customers that this is why they initially adopted Consul, and they're able to have considerable cost savings doing just this. There was a tweet just a few weeks ago about somebody who is totally cloud, full cloud, and just adopted this to eliminate application load balancers between services and was able to drop their networking costs by 90%. So this is sort of the bread and butter why you initially adopt the Consul. When we describe sort of the evolution of adoption maturity as crawl, walk, run, this is sort of the crawl step to get towards service mesh and some more complex solutions. After naming, once you have the ability to sort of name something, the next challenge that comes up is cool, you could address something, you could reach it. How do you control access to that thing? So the authorization problem comes up. And in a world where we're viewing everything as IP addresses, it makes perfect sense to use firewalls that operate on IP addresses as the mechanism to enforce this type of authorization. So using firewalls, you would do something like allow .51 to .104, and in that way protect access to your authorization services or whatever is back there. And again, in a more console-oriented world, as we look at things now through the naming aspect of logical service names, we are now operating authorizations, which we call intentions, through logical service names. So in the console world, you would say allow web to auth, the IP addresses sort of disappear, and authorization happens. And then finally, the last challenge is routing. And routing is really two aspects. It's the load balancing aspect of actually sending it to the correct instance, and then it's also the traffic shaping aspect, which is resolving it to sort of the right subset of the services you have running. So the load balancing is pretty simple. It's literally balancing load. And then the traffic shaping aspect is maybe you have V2 that you want to send 10% of traffic to, and so on. These are really important challenges to solve. And traditionally, again, these are done because we already have the load balancer with a load balancer, but it introduces quite a number of load balancers in the system and complexity as well. And with Consul, we're able to solve this sort of with our agent-based model, with a sidecar model, using the service mesh functionality in Consul. And so if we zoom out now with these three challenges and look at a traditional data center, it looked like this. There was a very clear north to south traffic path. You would have an external firewall, which is the big white box on the outside. Global internet traffic would come in the front door, which is a firewall. That would go to some front-end load balancer that distributed load to the web tier. They would do some processing, and then it would go back to sort of an internal back-end system like a database. And usually there was another firewall there. And these tended to be monolithic applications. They tended to be on VMs or in physical data centers, and they didn't move very often. They were fairly static. And so in this sort of environment, manually handling updates, manually updating firewall rules, using IP addresses is a perfectly reasonable thing to do. When there's not a lot of change happening, when there's not a lot of dynamicism, you don't need automation, right? But if we zoom out a bit more and we move forward into a more modern sort of deployment scenario, we start to see something like this. Where you might have adopted as sort of a new data center or a new location, and because this is sort of a new thing, you've also decided to re-platform onto some new technologies such as Kubernetes. And all the while, you sort of still have this existing system, and maybe you intend to move things from the existing system to the new, but that's never an atomic, instantaneous event. So there's always this period of time where there's multiple technologies that exist. And because the existing system's sort of there, it's very common that you have to reach back either for user data or billing or identity or anything to sort of come back to the old data center. So you have to set up something like VPNs or SD-WAN or direct connects. There's some mechanism you need to connect these two things. In addition, sort of you have a different point of entry into the second data center. There's now two ways for the internet traffic to reach you. And so the notion of a perimeter is starting to disappear. And more and more, this is very complex. And this happens actually fairly quickly for a company. So, like I said, even if you were a cloud-first company, if you existed sort of before the rise of containers or something, this is now a challenge for you, right? You have the cloud VM and the container challenge that you're trying to sort of bridge these gaps. Or if you're just a growing company and you're moving into multiple regions, this quickly becomes a challenge. And so let's zoom out one more time. and sort of see sort of the end scale, the end state of high scale sort of complexity that comes about, and the importance of networking sort of in that environment. So in this scenario, it looks sort of like complete chaos, but this is really more the rule than the exception, is what I've found talking to sort of hundreds of companies in the Global 2000. And what ends up, the way I want to describe how this happens is sort of with a story. It'll be an anonymized story, but true, based on the true facts. So let's imagine that you're a company that was actually cloud first. So let's keep it fairly modern. You didn't even have a physical data center, but you started cloud first about 8 years ago. You're cutting edge. You went all in on something like AWS. Let's say you just chose AWS as your cloud platform. And so for a long period of time, you invested heavily in tooling there. You have all your VMs there. Everything is homogeneous, and you're able to use sort of all the tools that AWS provides to have a very clean deployment. At some point in the past 8 years since that company gets incorporated, the rise of containers and container platforms starts to happen. But things like Kubernetes don't appear immediately, right? The first thing that happens are things like ECS or things like Docker Swarm or other sort of technologies come up. And so being the cutting edge company that you are, you quickly adopt these things, but you still have VMs and you're mixing them together. But it's still manageable, right? You have two systems. You continue growing as a company. Suddenly you have sort of global distribution, so you introduce new data centers. You're solving those challenges of having sort of multi-region capabilities. And then all at the same time, sort of Kubernetes is sort of standardizing the container platform like world. So you start adopting Kubernetes. Then function as a service, you can see sort of how this goes. So let's assume now after 8 years, you're a $1 billion company. You're doing very well. And as a business, at an executive level, at the business level, you decide that the best thing for this company is to acquire an adjacent startup company that's established, much smaller than you, but doing well. And so you go to acquire this company for business reasons, very good business reasons. But since they're newer, they've decided to go all in on Kubernetes on GCP. And so you bring this company into the fold, and suddenly you went from this very clean, pure AWS VM first, cutting edge company, to now having sort of this as a very real reality. And that happened to a real company. That was a cloud first company. And so you could sort of imagine, if you just stretch it to any other company that's been around more than 10 years, more than 20 years, that this is spanning clouds and spanning to their private data centers. It includes a lot more technologies. And so this is a very real challenge, and like I said, from what I've seen, is much more the rule than the exception. And so 2 years ago at HashiConf here in the US, we announced Consul 1.0. And after announcing 1.0, we have been focused, the Consul team has been focused on solving this broader service networking challenge. So release by release, we've been chipping away at this. And at HashiConf EU a few months ago, we announced Consul 1.6, which had really the largest sort of user-facing changes towards solving these problems. It announced 2 major features that really took it to the next level towards solving the service networking challenge. And I want to just quickly review those. The first feature we released was something called Mesh Gateways. Mesh gateways are a solution that allows us to automatically have cross-network service mesh. So when you have 2 networks that are either multiple data centers or VM to container or just have completely overlapping IP addresses, you're able to automatically make these connections work. We do it in a way that maintains full end-to-end encryption, because security is sort of an expected and necessary aspect of the network today. And our solution always spans sort of every available platform, so Kubernetes, VMs, physical, et cetera. If you look at the way I described service networking and the way it works, it's such a core technology to bridging multiple paradigms that it's only a real solution if it solves a heterogeneity problem. If you look at a single platform and you solve service networking or service mesh for a single homogeneous platform, that's solving a problem, but it's not solving the problem that we're seeing businesses have. The problem is bridging together multiple heterogeneous systems, and that is what we are focused on solving. So if we look at this from a quick diagram point of view, here are 2 networks. The most common reason you have 2 networks with the exact same IP address space is generally Kubernetes. So you have 2 networks, you have an API service in one, you have a database in the other, and they want to talk to each other. Because they have overlapping IP space, you can't just set up a VPN. You have to do something a little more creative. It's possible, but challenging. With Consul, you just put a mesh gateway on the edge of each of your networks, and the connections just happen. And to the developer, to the API service that's requesting the database, it doesn't even need to be aware that the database is in another network or it could be data center or anything. The API just says, I want to talk to the database. Consul figures out how to do that routing, whether it's allowed, and so on. So this is really important because I don't think developers should really care what the topology of the underlying system is. This gives sort of the freedom of the operators and network engineers underneath to move applications and do what's best for their sort of deployment, and things still work at the application level. And if we look at just a slightly more zoomed out example, this is how it would work across container platform, cloud VMs, and physical data centers. You would just put a gateway on the edge of each of your network, and now all of them can connect, even though this is either over the global internet or over multiple regions, et cetera. And so that was one aspect of the service networking challenge, right? The way I like to break service networking into two different categories. There's the networking part, which is sort of how do you get the byte from point A to point B. Like the byte just has to get there. And then the security challenge is also part of that. You want the byte to get there encrypted, likely. Then there's the other aspect of service networking, which is the category of progressive delivery. This is a term James Governor came up with. But progressive delivery is sort of an umbrella that encapsulates features such as canary, feature flags, rolling deploys. And the business challenge it's solving is the idea that we need to somehow have a mechanism to limit risk when rolling out new software. And this is one aspect of limiting risk. You probably also want testing in different environments and CI/CD and so on. But bugs get to production. They always get to production. So how do we limit the blast radius of deploying these applications? And as we're now reaching the point where it's fairly mainstream for companies to have hundreds and thousands of microservices that are going out to production, how are you supposed to do this safely that doesn't bring everything down to its knees? And so the features underneath progressive delivery are the way you do that. And so with Consul, we also announced layer 7 functionality to do HTTP and gRPC routing, traffic splitting, and custom service resolution. And all of these solve the sort of the progressive delivery aspect of service networking. To show this in a diagram, this is what, prior to Consul 1.6, when you asked for the web service, this is what it looked like. Consul would just look up the web services and return them to you. In Consul 1.6, you can now introduce logic in between these, and all of them are optional, but this is what the full chain would look like. You could do routing, traffic splitting, and resolution. And so to run through a quick example of what this does, sort of at step 1, we could do routing to say, if we ask for the web service but the /admin path, that goes to the admin service. And then when we're in the admin service, we want to split 10% of the traffic towards V2 and 90% towards V1. So we split towards V2. And then finally, the resolution step actually informs Consul, how do I resolve the V2 admin service to an actual instance? And so there we're able to say, well, all the services named admin that have a metadata of version equal to 2 are that service. And so finally, the green boxes are what Consul determines are what you want to talk to, and it returns those all the way out. So you can see how this sort of functionality lets you do this progressive delivery. And so all of this is in Consul 1.6. We announced that at EU. It reached stability in a final release about a month ago. And so this is all out already. But we could see from this sort of the importance that networking plays in this sort of multi-everything adoption, multi-platform adoption, and sort of the critical functionality that Consul provides. And so it's very important that Consul is as easy to adopt as possible. The Consul core team has been doing really good work every single release to make that easier. If you look back at the past few releases, we've made securing by default easier. We've made introducing ACLs easier. We've made upgrades a little bit easier. There's been, little by little, we've made things easier. But we always wanted to do more. And so we went to the drawing boards, like, what can we do to make Consul easier to adopt? And an obvious answer stood out, which is we could run it for you. And so today, I'm excited to announce the HashiCorp Consul Service on Azure. So HCS on Azure is the easiest way to launch and integrate service discovery and service mesh It is Consul as a service, and it is also the first fully managed service mesh as a service. The features, as a service, you get the features you would expect. We provision Consul clusters for you automatically. We handle backup and restore. We handle upgrades. We handle scale up and scale down. And all of this is consumption-based pricing, time-based pricing. It's not a big upfront commitment. By integrating very deeply with Azure, we're able to keep Azure native identity and billing. So with this release, you actually are able to, you don't need to sign up with us. You could use an Azure identity, and our costs show up on your first-class Azure bill and are billed directly through however you pay Azure. But all of this is HashiCorp managed. So when you create a Consul cluster, when a backup is necessary, when we perform an upgrade, all of that control plane work is handled through software that's built and run by us. It runs in our data centers, or cloud data centers. The software is written by our engineers, et cetera. We've hired and built out a HashiCorp SRE team that is handling the management of all the customer clusters. But all the while, we've partnered with Microsoft to sort of deeply integrate across from sales to technical implementation. As a quick diagram of how this works, but we'll run through a demo, but a quick visual diagram starting in the middle and then going right and then left. So you would find the HCS sort of application. You would ask us to create it. That comes back to our software, and we handle the creation. And the creation of the cluster actually shows up in your account in a managed group. We have access to modify the resources just in that group, but by putting it into your account, you could easily do VNet peering or handle any way to sort of get access to those Consul clusters. This is way easier to see with a demo, so I'm going to just show you a recorded video of what this looks like. So what we're going to start with here is the page you would see after hitting Create Consul Cluster. And you'll notice this is just right in the Azure portal. It feels just sort of like a first-class system directly in Azure. And so this is the first thing you see. So I'm going to start the video here. One of the first things we'll show you is selecting the region. We are supporting right away at launch every single Azure region that they support, every single public Azure region. You would select your resource group that you want to launch this in. You could create a new one, which is what we're going to do here, empty resource group to launch all the Consul resources into. And then after this, you hit Next, and you're presented with a bunch of Consul settings. So you could name your cluster, name the logical data center, choose the Consul version you want to deploy, determine your backup and upgrade behavior. Do you want automatic upgrades? Do you want manual upgrades? What interval do you want us to take snapshots in? There's a number of options here that you could choose. So you go ahead and choose them, hit Next. We validate the configuration for you, and then once it's valid, you could hit Create. That initiates a deployment, which we'll click into here. The deployment takes a few minutes. We fast forward it in the video. But the deployment takes a few minutes. Pretty soon, you'll see an HCS instance show up right here. And then very shortly after that, that'll become clickable. When you click into that HCS instance, you land on an HCS on Azure dedicated page. And you'll see in the sidebar a bunch of Consul-specific things. So the first one we look at is the Consul clusters list. This lists all the clusters you have. You could add more. You could see metadata about it, the version, so on. And if you select the cluster, you could do a bunch of manual steps, such as manually forcing a snapshot or manually performing an upgrade. And then in the left-hand side, you'll see a link to the UI as well. So we click that here. And when you click the UI, it loads the Consul UI directly in the Azure portal. This is a lot fancier than it looks, actually, because what we're doing here is when we deploy a Consul cluster, we deploy everything secured by default. TLS is fully set up, ACLs are fully set up, gossip encryption is all there. So when you load this UI, you'll notice that there's sort of no token entry required or anything. Since we integrate deeply with Azure, when you clicked that button, we were actually able to use your Azure identity to prove that you have access to the Consul UI and log you right in. And so you get access directly there. You could also choose optionally to put the UI on an external endpoint if you want to handle access yourself, or you could keep it private and only access it through the Azure portal. And so this shows you sort of the quick example of HCS on Azure. Like I said, we've partnered very deeply with Microsoft. We're excited by that. And to talk more about Microsoft and Consul, I want to invite to the stage Brendan Burns, a distinguished engineer at Microsoft.
Great. Thank you. Thanks, Mitchell. It's been really great to develop this partnership with HashiCorp and see the benefits that the combined forces of Hashi and Azure can bring to our joint customers. Because the truth is that when you're building applications in the real world, it's a really complicated hybrid environment. You need the ability to interact with both existing services that may be running on VM-based infrastructure, with newer microservices that might be running in Kubernetes, in the Azure Kubernetes service. You need to be able to have all of this stuff work on-premise as well as in the cloud across a wide variety of environments. So most applications that we see out there aren't the pretty diagrams that you see in the cloud-native application portfolio, but rather a complex collection of pipes going in different directions. And the combination of Azure's technology and Consul can make a really great way to bring those applications together. To give a demonstration of this, I'm going to go through our legacy application that we're using Consul and Azure to help modernize, and that is Cloud Pong. So Cloud Pong has been a successful legacy application. Well, it started out as a new application, but it became a legacy application based on virtual machines, hard-coded IP addresses between the different players. Pretty happy with it, but our agility isn't just where it needs to be. And so we're going to microservicify that thing. We've gotten, if you've seen the recent Dilbert cartoon, we had the pointy-haired boss come in and say Kubernetes to us. So we're Kubernetes-ifying our service. But as we do that, the question becomes, we've got these services over here. Kubernetes is cloud native, and that's wonderful. But we still have this VM based for our second player, and we have to do this migration successfully. How can we make sure that we bridge the world of dynamic services in Kubernetes with a more legacy world of virtual machines? And it turns out that to do that, Consul is a great solution. Right? So Consul is something that we see with our customers a lot, specifically around this notion of bridging from a mesh that's in Kubernetes and a mesh that is in other environments. But the question is, how do I drive this? How do I make this work in a Kubernetes-centric way? And how do I ensure that, if I want to use other service mesh implementations, because at this point, every couple of weeks, there's a new service mesh being announced, how do I make sure that it all works and that I'm learning and my tools can use the same thing? And so to do that, a while ago at KubeCon in Barcelona, we partnered with HashiCorp and others to come up with the service mesh interface specification. It's an open specification. It's out there on GitHub. And you can use this open specification to drive your service mesh so that you're not bound to any particular implementation. You can use Consul if that works great in the managed service on Azure. If you're in a different environment with a different implementation of service mesh, you can use the exact same Kubernetes objects to configure and set up your application. So to give an example of this in the real world, I've actually deployed exactly this architecture out onto Azure using Consul, using the Azure Kubernetes service, using a legacy VM. And I want to give a demo of this. So in order to do that, we're going to have a demo of Cloud Pong. But of course, you really can't play Pong without another player. So to do that, I understand we have a volunteer from the audience who's going to come up here, and we'll do a little Pong on stage for you. So this is the step to any successful startup. Grab our volunteer. Something magic will happen, and hopefully we'll profit out the other side. So come on up. All right. Thank you. Thank you so much. All right. Let's get this set up here. We're going to keep our fingers crossed. Oh, is my screen? Is my screen on there? I can't actually. Oh, my screen is there. Awesome. Cool. All right, so I'm going to set up my, my game here. Many thanks, by the way, to the folks who helped me build this. And over here, we're going to set up player 2 for you. Sorry, I'm going to type a little bit for you. But it looks like player 2 is not connecting. We're not actually seeing player 2's, the paddles or the ball on player 2's screen. So she's going to be at a disadvantage. I'm going to win. No, I'm kidding. And it turns out the reason for this is because Consul, as Mitchell mentioned, is secure by default. And if I go over to the Consul UI here, what you're going to see, if I hit refresh, is that, this is my, I'm just going to show you that this works, even though I didn't reset my demo. Does that mean I win? You win. No, so I'm going to show you how the SMI is able to control Consul. So what you see here is none of the intentions are there, which is not allowing the connections through Consul from player 1 to player 2. We can actually use the service mesh interface here to create those intentions. So if I actually take a look at the policy, these are Kubernetes objects. I can actually show you the policy. So these are actually Kubernetes objects that control the connections between the services that are exposed in Kubernetes and the services that are exposed on the VM. If I go ahead and create those, that says delete. They're not there. Deleting doesn't work. I'm going to create the create. See, live demo. All right, so now we've actually created those. We'll go back over to console. We're going to hit refresh. And the intentions are there. So now if I go back to my Pong, all right, and we'll go back to your Pong, and we will try and reconnect, and we are ready. All right, you ready? So it's arrow keys up and down.
Okay.
Space bar if you want to hit the ball. Although it's my serve, so.
Okay.
All right, you ready to go?
Yep.
All right, here we go. It's thrilling. We needed a play-by-play. I should have a play-by-play announcer. Is it not? Hold it. Try holding it down.
This is rigged.
It's rigged? No. Oh, maybe is the menu? Oh, see, there we go. All right. Well, where's your mouse? I'm gonna make sure your terminal's selected here. It's max. All right. Let's see if the spacebar works. Spacebar. And we'll try this again. I want to give you a fair shot at this after all.
I appreciate
Yeah, I mean
that.
really. All right, let's try it now. No? All right, well, I'm gonna have to apologize. I don't think, I really didn't intend for me to be the only one with controls that worked. But I guess that's the situation we find ourselves in. So you have to at least I can make my controls work. All right, well, thank you so much.
You're very
I
welcome.
really apologize.
Great game.
Thank you. Yes. All right. Thank you so much, and we're gonna have Mitchell come back onto the stage and tell you more. Thanks. Oh, clicker. There you
Thanks.
go. Thank you.
All right. Well, that demonstrates the importance of progressive delivery, I think. Yeah, OK. So Brandon showed a good example of sort of how you could use Consul and integrate Consul in a Kubernetes and Cloud VM world. This is a super common deployment today. But I also showed earlier, in addition to that, the addition of private data centers. And many private data centers are out there running VMware technologies. And so we want to make it as simple as possible for Consul to enable service mesh across all of these environments. And so to help talk about this next step of going to private data centers with VMware, I'd like to invite onto the stage Pere Monclus, who is the CTO of Networking and Security BU at VMware. Pere?
We saw this morning a discussion with Armon that everything was going multi-cloud, multi-application, multi-service. At the same time, we were seeing from Mitchell the idea that networking is much more than IP address and connectivity of switches and routers, but it's evolving towards providing what we call service communications. And within this new world, what we are seeing is that customers are coming to the industry and essentially demanding, how do I connect these environments across multiple silos? So today, from every time I deploy a Kubernetes environment, every time I create a cloud-native app, every time I go to a public cloud, essentially I have a microcosmos of operational models, security models, identity models, connectivity models. And what happens is it's very difficult to eventually operate the whole thing as a cohesive system. So we started working within a group of companies, and we started realizing that we couldn't repeat some of the patterns of the past, of the notion of saying, we have an environment in private cloud, in public cloud, in Kubernetes, and they are kind of isolated, managed by different teams. So we started discussing about this notion of how do we understand what a service is across heterogeneous environments? How do we connect a microservice in one side to, let's say, a VM on the other side? And it was going back to the fundamentals of what connectivity is. This is kind of the evolution as we go to the service networking that we were discussing with Mitchell. This notion that it's not anymore about connecting from IPA to IPB, but rather how to understand identity across environments. How do we understand end-to-end connectivity? How do we understand policy? How do we understand service discovery? So for that, we started working and defining in an open standard with open source with a group of companies, how to essentially exchange information between two disparate meshes in a way that from an operations and visibility point of view, they could work together. There is a session today in the afternoon that basically we go into the details of how Consul Connect federates with a service mesh project that we have at VMware NSX-ServiceMesh, and how you see an end-to-end connectivity on those. That's an open framework that we are working with in the community. There's participants like Google and other players, and essentially allows you to stretch the notion of this service networking, this service mesh, across multiple environments. Now, provided that we do that, then we achieve essentially this end-to-end, what we call enterprise class service mesh. The idea is the fact that now we can essentially discover, monitor, control, have consistent policies across all the environments that you may have from a service point of view. Now, within that though, when we were talking to our customers, we were seeing that this was potentially not enough. I mean, if you think we are very focused on how a service interoperates with another service. But as we go to these layers of communication, essentially, as we move from traditional networking to how microservices communicate, the picture is much more complicated, because now as we get inside the semantics of the application, what we have is that services are there to provide some useful value to the users that connect to those services, the authentication aspect of what user connect to what service. And eventually we end up writing to a data object. So now within this evolution of networking, service networking and communications, what we are building at VMware is essentially expanding the meaning of what you connect, which in this case was a service, to something much more broad, like how a user connects to a service and how this service on behalf of that user writes into a data store. That allows us to essentially have what we were discussing before about spreading this mesh across multiple compute environments, multiple clouds, but at the same time extend it to these three principles in a way that when we discover what services do we have, we by definition discover what users authenticate to those services and what data objects are being written. In a way that then when you have the visibility of understanding what's the SLO that you observe from a microservice, you could say what's the experience that the user is seeing from that entity. And as you go to the control, you could start thinking in terms of why are users in Europe writing into objects in the US? Is this a GDPR violation? So as you see, the notion of going to the service networking or the service mesh concept, it's a fundamental transformation because now it brings capabilities that before were like hidden in multiple layers of the infrastructure. Now you can get closer to the business policies of what you intend to do and use the deeper semantics that service networking has into the application to provide that. Now, of course, and it was discussed before, this is not just about how to create connectivity across cloud native or connectivity across multiple Kubernetes clusters, but is how do I extend whatever service mesh concept I may have in the cloud native wall, how do I extend it into the virtual machine wall? How do I extend it into the physical mainframes and bare metals? To that extent, we are, of course, integrating with different components of the VMware family and different partners outside on how to make sure that we can communicate the current service networking of the cloud native wall to the previous one that Mitchell was discussing about load balancers and IP connectivity. So just to summarize, we are very excited that to be part of this collaboration with HashiCorp, because essentially in this multi-cloud, multi-service transition that we are going, the only way that we are going to satisfy the requirements of an end-to-end security model, an end-to-end connectivity model, if we start working and collaborating more in these frameworks about how to federate environments to solve end-to-end problems. Thank you.